Good morning or good afternoon, everyone, and welcome to our webinar. The webinar is hosted as part of the ASTRAIOS project. ASTRAIOS is a European Union funded project working on identifying the status quo when it comes to the educational offer in the space sector in Europe, to identify also the skill demand as identified by the European space industry, and to define actions that will allow us to align and to improve the career paths into the sector. Our project started in January 2023 and will end up this December 2025. Today, we will be talking about from space to place, mapping inequalities in complex urban spaces by combining Earth observation, artificial intelligence, and citizen science. And the talk will be given by Professor Monika Kuffer. Welcome, Monika, and thank you for being here today.
Thank you, Marlena, for the introduction. I think the slides are already up, and I'll just start the slideshow. And let me know if the slides are now well visible. So as my colleague Mariana nicely introduced me, I will talk about what I was framing from space to place, which means that we all work in somehow in the space Earth observation industry, and I want to sort of promote people to understand the local context, because what we see and even more notice nowadays with more and more data being available, that people often produce data and work on spaces they don't understand the local context, and produce data which are then not very relevant to the local context and might be very harmful to the local context. And this is, of course, in general, important. This is also a general statement, but even more important when we talk about very sensitive spaces to map, what I was framing as mapping spatial inequalities. I'll have also some slides later to define what I mean, or what are examples of spatial inequalities, which you can see as spaces which are excluded, and what you already see on this small window of a very high resolution satellite image that you see on the right side of space, which has beautiful services, houses, even swimming pools, and a space which is very excluded from all kinds of urban functions in terms of accessibility, infrastructure, greenness, etc. So the local context and the local understanding when we map those spaces is really essential. And I will go through a lot of examples and sort of challenges and reflect throughout my talk. As Mariana was asking me before whether she should introduce myself or not, I was saying I have a slide. It's to introduce myself, and I was tagging like ongoing and recently completed projects in the context of the SDG, the Sustainable Development Goals. I work a lot around urban sustainability, and urban being not very broadly defined as really only the core city, but really urban going into the also the peri-urban spaces, and also seeing some linkage to rural spaces, as we all rely on food, energy supply from those spaces. So as you see, I've been trying to tag some ongoing projects across SDGs, just saying that I'm working together with many colleagues, also including Mariana here in the room, on the ongoing research across many SDGs, with a focus, of course, a lot around SDG 11 on cities, SDG 13 on climate action, but also other SDGs linking to poverty, to peace, etc. And one of the sort of important discussions, and also ongoing discussion actually this week, there are a lot of meetings from UN Habitat around SDG monitoring and developing future ideas of SDG monitoring instruments, where Earth observation data can play a critical role, because what you see, and that was also said above, sort of the rescuing of the SDGs, is so we are basically not in track in many of the SDGs, but we also don't know how far we are off track on the SDGs, because we have not very efficient monitoring instruments, and data are often very dated, country level aggregates, where we even don't know whether the trends are correct. And I take one example of a recent work, which I don't have on the slides, is where we basically compared the SDG 11.1.1 indicator on slums and informal areas of Argentina, and the data from UN Habitat, the country level reports show a decrease of population living in informal settlements and slums, while data we generated, or basically we were working with together with local partners from RENABAP, which is basically a government organization, a slum registry of Argentina, shows the opposing trend. So basically they record that population as well as area increasing over the last 5-10 years. So it shows that even those trends are not certain, and therefore Earth observation data can fill really a critical role as monitoring instruments. And in these meetings, UN Habitat is very sort of encouraging and very interested about developing further monitoring instruments, building on geospatial data and particularly Earth observation data. But as I have been using spatial inequalities, and so some of the photos are not that pretty. So these are photos taken from either friends or myself in the field. But I was trying to describe what is actually spatial inequalities and how it expresses in spaces. So what you see on the photo is like a flood which happened last year in Nairobi. And it's not a very deep flood. And together with two wonderful PhD students, Enzo and Lorraine, working on these topics, what we conclude and what we see in interviews with stakeholders is whether this would be seen a flood. So this might be not qualified for the typical threshold of a flood model, which is 15 centimeters. But if you go to areas which are slums, informal settlements, this flood level of maybe below 15 centimeter will have a massive impact to the life of people. It will destroy it because it will go into their houses. Sewer systems are not well in place, so sewage water will enter the houses of people, and it will have a massive health impact, or even weeks after this flood occurred in the area. So whether this sort of relatively low-level flood is a flood depends. It depends if you live in a well-built-up, in a well sort of formal area which has a good drainage system, sewage system. Then this might be will be maybe a small nuisance, but it's not maybe a flood. But if you live in such a settlement, this is a flood to you. Also, what is a big question in many settlements, which is often not documented, are reoccurring fires. I'm just back yesterday from Nairobi, and there was some smoke coming up, and then I was in one of the informal settlements, and people were saying, "Oh yeah, it often burns. Like it's a way of solving land conflicts." So it's a reoccurrent situation of areas and houses being lost and burned down. And this was an area I visited 2 years ago together with colleagues. It was a marketplace, and it burned down in the night. I was in the airplane, and on the next morning I got all these messages from colleagues. Oh, the place burned down. And the question why it burned down is infrastructure related, of course, is can fire trucks reach these areas? And fire trucks can not reach large part of the population. And the large part of the population in Africa, in African context, we talk about 60% of the urban population. So 60% is living in these areas which have not services, which are where people are not having access. If a fire starts, that a fire truck enters. Also, in terms of access to light, it's a bit of a weird looking image. It's an SDG sat image, a nightlight image. And the question is the electricity, and large part of the urban spaces are not supplied with, at least with reliable electricity. And it depends from country to country whether there is some sort of electricity for the majority of population. There are some places, even in urban areas, like South Sudan, where it's insufficient supply at all for electricity. In most cases, like Nairobi, Lagos, or many other places, it's more the stability of electricity. Another important topic, and just imagine if you not have this experience living in such spaces, is the question, and you see a map which we collected in a field together with local communities about the location of trash piles. Trash is basically an enormous problem, also in terms of flood management, and the location of trash pile often defines where the flood occurs. Basically, trash is not picked up if you live in an informal area. So we talk again about, to remember, you 60% of the urban population which is not having access to regular pickup of waste. And that's all something we can monitor and document in with satellite images, depending to the context, of course, nightlight images or daylight optical images. So a very small context slide, and that's what we basically have to keep in mind, that we have this rapid urbanization trend. So it's estimated until 2050 that about 70% of the population will live in urban areas. And the vast majority of this growth will happen in low and mid-income countries, an estimated 90%. And we have already massive housing inequalities, lack of infrastructure services, which will be in the context of this rapid growth increase. What we as Earth observation community have a problem doing is we often only focus on the primary city, and it made some comparison of publications over last 10 years with a focus on deprivation, slums, informality mapping, and the majority maps on primary city, repeating always the same cities to be mapped, while the urban growth is happening with a very strong focus on secondary cities. So that's something to think about. Also, a big problem with research and continuity of research is that we as a researcher often sort of work from project to project. We have funding for a while, then we produce something, and then we close. We end with a publication, but this publication may have scientific impact, but not societal impact necessarily. And therefore, I really encourage people to think about how to build on top of projects. And that's an example on how we decided to build up on top of project. It's IDEAMAPS, which stands for Integrated Deprived Area Mapping System. And we had an initial network grant, and we are basically building now projects on top of each other and trying to develop the whole research field further with all kinds of branching out projects linking to aspects of deprivation, like nightlight images, which link to access to electricity and street lights. Also a lot on, let's say, building different data systems around heat, stress in such settlement floods, but also looking into capacity development, like data for human rights, to open data not only to scientists, but also to community activists to use data for advocacy campaigns. I can talk ages on this, but it will continue. So one of the contexts we're also operating is this massive disruption of data systems. So with all the budget cuts, for example, from USAID impacting the stop of DHS programs, which have been used in many of also geospatial models, we will have in the future much less socioeconomic data we can use in our models. Therefore, Earth observation data can fill a gap, but we also need to be sort of mindful how we can fill these data gaps, which we typically use for our models. And one of the sort of related problems are censuses. So censuses, for those who don't know it, in the Netherlands, basically the funny thing is nobody knows a census because the Netherlands has not a census. So it's typically every 10 years a country would count the people, it would have socioeconomic data. But what we see on this map from a colleague, that many of the censuses are very dated, and particularly in the most conflict-prone parts of Africa, But there we have the massive population dynamics, so we don't know very much what is happening. And the data we have from the UN about how many people live on the Earth, of course, are therefore with very high uncertainties. So what we have been developing as a core framework around IDEAMAPS is how can we model deprivation to go further than to categorize now here on this image, one area as informal and the other area as formal, because that's nice for global maps, also very nice for global maps for SDG reporting, etc. This kind of binary situation is good, but for local action, we need really much more fine granular data about understanding the diversity and the issues on the ground. And therefore, we developed this framework what defines deprivation with a large set of indicators, but putting them in 3 scales, which the 3 scales are the household level scale, the area level scale, and how areas are connected, and in what we call domains of deprivation, like housing deprivation, contamination, hazards, and all these domains have, again, a set of indicators that are measurable with geospatial data that relate to aspects, for example, of floods, to temperature, etc., but also has outcomes of areas and can be aggregated into what we would call like a degree of deprivation index on a city scale to show the best and the worst areas in terms of deprivation, so the areas where action has to be happen, but also can be disaggregated again to specific indicators to understand what is area actually lacking, but also what assets those areas have, because we often look only to the negative sides, but it's very important for local development to understand what are the capacities of areas. So in IDEAMAPS, we have, as you showed, various projects. One of the bigger running projects is the IDEAMAPS Data Ecosystem, which is a Gates-funded project where we build like a whole ecosystem combining this layered information and making them accessible to local communities. We had just last week in Nairobi an activity in a workshop where basically this layered information system were fed back to local government representatives, to community representatives to understand and to show how spatial data, the variation of spatial data on their areas. And it allows to local users to provide feedback. So on this individual grid cells, and we do like this, what you see here on different aspects of deprivation, be it now accumulation of waste, but also access to healthcare system for women if they need to, like particularly if they are pregnant and need to deliver, what are the barriers of accessing, physical barriers of accessing flood, etc. And we built this layered information systems showing particularly the most challenging areas, but being validated by massive amount of workshops. Other aspects that are within one project we are doing on urban heat, which is a very important aspect of informal settlements. What you can see maybe already on these pictures, if you have never been on such of this settlement, in one of such settlements, that housing materials are often iron sheets, roofs, which are warming up very quickly and bringing for the inhabitants a very unpleasant climate inside the houses, meaning quite high temperatures. Even so, maybe outside it might be not that terribly hot, but the whole area also heats up if you have like a very almost continuous surface of metal roofs. But as Earth observation community, we often only map the surface temperatures, but never see how the surface temperature relates with air temperature. So in this project, we have been developing like a low-cost sensor-based measurement system, which you see some the instruments we use. So we used one of a very sort of accurate measurement station, but had this transect walks through the settlements where you see some pictures. And basically the sensors, they were on a stick together with a GPS that we could locate, and we could build a very sort of detailed temperature profile through the settlements. which helped us again to model with Earth observation data the entire settlement, also the entire city, and to look into which areas are the most impacted by extreme temperatures. We also had, like 2 months ago, a workshop with local stakeholders, bringing this information back and developing ideas on what kind of mitigation measurement could help. Mitigation/adaptation measurement could help to cool down some of these areas that are local, sensible, and contextual measurements. And there were a lot of ideas and to be followed up in some further work on that. But what we basically could see, and that's is that the temperature variation is within a few hundred meters quite extreme, up to 6 degrees. If you live in one of the very densely built up informal settlement, as compared to a few hundred meters away in a quite nicely built up space with green infrastructure in it. So it makes really a difference for people. And this we have been feeding into one of the data portals we have together with colleagues from the University of Brussels, University Libre de Bruxelles, where we put all the data we produce into an open platform, which can be also then downloaded for other researchers to continue. And we do this typically in a gridded format, which I have been not mentioning, trying not to typically 100 by 100 meter grid, out of ethical reason that we don't show the exact location, but provide more average at 100 by 100 meter grid cell. Similar to the aspects of heat, another important problem for people, our colleagues living in informal settlements, are flood, the reoccurrence of flood, and also the undocumented scale of floods. If you go to one of the data sets, for example, from the European Commission, you will find out that a city like Nairobi is recorded as 0% flood exposure. If you talk and if you tell this, somebody living in the city will be like laughing to you, basically, because the city is very regular flooded, and typically the low-lying informal settlements are reoccurrently flooded. The problem is that most flood models are not very good to capture flash floods. And therefore, together with a PhD student, Lorenzi is looking into how the flood information can be brought or made more context specific and include also the very complex situation of informal settlements. This is paired with another PhD student, Enzo, working on how we can sort of understand livability. And this is a beautiful app which has been developed some years ago by a colleague, Angela Pascal, on a previous research where basically citizens, so we run massive workshops where citizens can rate which area is the better area. And therefore we can build city scale maps on livability, variations of cities. And what you see on the right is an example of Accra in Ghana, where you see that it ranges from the least to the most livable places. Red is the least livable, obviously. And this is something we scale up in this project across 6 cities, always comparing like a secondary and a primary city in this project to bring another perspective to deprivation, which is the livability of places. And I was surprised because I thought I had a nice video, but maybe I put it on the wrong place. Sorry. So this shouldn't be here. Yeah. Sorry. So that's basically to explain you what defines livability is. I'm just back, as I said, yesterday from Nairobi, and we did like a workshop of mapping this livability, and this is a part of Nairobi, which is Mukuru. And what you see on the image is a situation on the left from 2000. And the area has been evicted in 2001. So you see basically how the area has been totally changed. And we have been sort of mapping the livability aspects in the settlements on Monday. And what you see, this is now basically now the situation in 2025, that this area has been again rebuilt, but rebuilt in a very problematic way with very temporary shelters and people living in more tent type of structure, particularly the poorer population at this present situation. And that's a very short video of when we how this mapping works. So basically, people in a workshop get first a context how to work with satellite images, and then they start voting with this app to say which is the better place and which is the worst place to live. And this is, we do this from settlement to settlement, which is in the moment ongoing. Also today, in the moment, there are actually people voting in Nairobi. And we also went through the settlement, through this part which has been evicted, which some really positive outcomes, like this was a recycling house they produced, but very strong. And that's a shocking situation where people live still in tent type of structures because they have been evicted 2 years ago and they could not recover since then. So the whole infrastructure in the settlement has been very degraded, like it has not been catching up since then. If this works, go to the next slide. Good. So that's on livability mapping. So which is very much producing data which are very location and very sort of granular in terms of the variation of livability conditions. We also work with UN Habitat together on developing Earth observation-based SDG monitoring instrument around SDG indicator 11.1.1, which is on the proportion of population living in slums and informal settlements. And therefore, we have been developing a method that produce like global scale information. We started with a pilot of 8 cities, which have been now added with additional, so far with additional 6 cities to transfer the methodology. But we are working on more expansion cities, which is in collaboration with the Inter-American Development Bank and TECHO, which is a local like very much in Latin America operating NGO. They're also globally operating. And also adding to local data questions, like our colleagues from Argentina, who have a quite good registry, but they are very slow in capturing new developments. So we are now trying to see how we can tailor our methodology to their needs to update regular their settlement registry. And the whole sort of workflow is that we start with on a very local context and local context understanding around living labs to understand what the local information needs. And then we also feed back to it's like a model should be never a final solution or a final outcome, but we have these iterative circles where we have a first model and we feed back the model to our local stakeholders to improve the model after feedback. And I'll explain how this works. So we started with comparing different satellite images, also more commercial images, but we basically tried to build our model around free cost images, meaning Sentinel-1 and Sentinel-2. We use, as part of an ESA-funded project, we use a cloud computation infrastructure, CREOLIAS, which makes the computation relatively efficient. And we developed with our colleagues CNN, a very light-weighted CNN, to make the computation relatively efficient with inputs from Sentinel, but also having inputs, for example, from building footprints and morphometrics. And then we predict 3 classes, which are basically non-built-up, formal built-up, and informal built-up. And this information we feed into what we developed together with our colleagues from GeoVille, an IDEATlas data portal, where users can see the prediction, but also the reference data, and can provide feedback in terms of correction of this area. So if the model predicts an area as informal, but the reference data says it's not informal, we ask our local partners to decide whether maybe the reference data is wrong or outdated or incomplete, or whether our model is incorrect. And this information we feed again into rerunning our models. So as I said, we have been doing this for this 8 initial pilot city, and now we're working on a set of expansion cities to really see how we can scale up and also do hopefully some country level expansion. So we did first experiment with Guinea-Bissau, but of course it's a relatively small country it's more the size of a city in places like India. But also informality is, so I've been mostly talking about informality in a global north context, but of course informality also exists in Europe, and that's also something in future maybe to be added. An ongoing work together with colleagues, which has to do with what you have been seeing also before in the story around Mukuru, the massive destruction which happened, and this is something which happens relatively regular across cities. And we have been often called by our colleagues from local community-based organizations to support mapping and to support also even court cases with maps. And we have been developing this idea to develop what we call a permanency observatory that supports local communities in their fight for their land rights with Earth observation data, because they typically lack the mapping opportunities. Even so, we have been developing also some basic training materials around how to make simple maps for community activists. But they often rely also on historic maps. In many countries, you need to prove, for example, 10 or 20 years of existence in a certain place that gives you a certain level of use right over the place. And therefore, historic images are often a very important asset to them. And we have been sort of, at the moment it's nothing finished, working on developing some ideas how to support mapping initiatives, but also how to use Earth observation models to flag where actually evictions are happening. So my final sort of number of slides are around nightlight images. I think I started my story about how nightlight images can help us to say something about presence of light, presence of electricity, which is of course only like an indication if it's dark that there might be not electricity in an area when the area is built up. And I think in the last years we have been getting, in the last decades, I remember when I was working the first time with nightlight images, they were very coarse resolution, and that's what you see on the right, like the OLS images of 5 kilometer resolution were then brought down to they are resampled to 500-meter resolution image, the VIRS images. But we have been seeing now in the last years more and more high-resolution satellites like SDGs, which are now down to 10-meter panchromatic at night, which provides us a very interesting new insight of our activities, human footprints at night, and are saying that lighting is an important aspect to when we talk about also about energy, our energy footprint, saying that accounts for about 20% of the global electricity consumption and has a massive CO2, quite a substantial CO2 contribution. And the sort of just an example how this different resolution allows to see, but also omits area, because like many studies are still using the VIRS type of images to say whether an area has access to electricity. For example, in many of the World Bank data sets, they have been using VIRS images to say, is there electricity? And the problem is what you see, like an area that's an area in Cologne, in Germany, not somewhere in the south, but we use this for an experiment to see. It seems the whole area is lighted in the VIRS images, but if you go further and further to more high resolution, you see that there are many dark spots in between. And that's something you don't see in the very high resolution. So an example we did in a recent publication to see what are sort of potential interesting application areas, like very obvious, what is very often used in terms of nightlight application is when a civil war starts. That's in the example of Yemen, the total drop of night lights. but also the impact of environmental health-related activities, which means the shielding of streetlights. Often streetlights are not properly shielded, which have a big impact on night active animals. And you see the impact of shielding of nightlights, but also the seasonality of tourism. You see here down, which is the example from Ischgl in Austria, where you see like in the winter season, you have the peak because it's a very winter-oriented skiing resort, where you have a massive differences in seasonality and obviously the economic growth, which is very often used in nightlight studies. What you also can see, and that's the beauty of now the use of SDGs, is the shift in terms of the type of lighting used. So what you see here is the shift from the very orange, more yellow lighting, the traditional bulbs, to LED lighting, which are more energy saving, which can be seen in RGB nightlight images. VEARS, by the way, is not RGB, and that's an example of a beautiful map a colleague was putting together on full mosaic. They are now having a mosaic also of whole Europe on SDGs to see how different areas are lighted. And these are some examples from my own work. I've been working for many years in a project in Sudan, and we just left Sudan the last time in March 23, which was a bit scary because the conflict started in April 23. And you can see the impact of the conflict. So this is just a few days apart, how a city has been, the whole infrastructure has been destroyed. And it's not only the street lights which are gone, but also typically it means that the whole water system is not operating because water systems require electricity. And that's a most recent image where you see basically that the city is totally like deprived of access to basic infrastructure. We are working, as I say, a lot on informality, deprivation, and so we have been also asking ourselves what are potentially these red spots in the nightlight images, and we have been tracing some of these red spots to burning of waste at night, which is very cumbersome environmental and health situation, but people don't know how to deal with waste. And also to make you understand what it implies if you don't have streetlights. It's a big safety issue. It has a strong gender dimension if you don't have streetlights at night. But also going along this very narrow alleys with a lot of obstacles, and that's a photo I took in the field. So you fall very easily over things, and you have a lot of pipes, waste, etc. on the street. So having not streetlight in those areas, which is a massive issue on the night. And we have been counting like how often the light actually went off, what are the power outages, and basically what we concluded you can see like for quite we studied for like quite a couple of days. And then it's one of the informal settlements in Nairobi, Kibera. It's that like every second day the light went off, and it was about more than 3 hours of electricity, I mean. And that's what you also can see when you compare that's Lagos and Nigeria, that like deprived areas are having much less access to light as compared to the rest of the city. What we are now working on is bringing, let's say, also looking into the future of cities. So to see how Earth observation data can be used to model the future of city, the growth pattern of city, but also relating them to environmental outcomes in terms of heat, air pollution, etc. in advanced simulation models, taking now also a European case into account and looking into also which parts of the city will be most exposed to problematic environmental outcomes. I think I'm already almost overdone. I just want to acknowledge you have been seeing on the bottom, I used a wonderful graffiti, which I was taking a photo on Saturday. And on the right, you see the main artist, Lawrence, with his group. They have been making this graffiti of their future and their hope of one of the informal settlements. It's from Kibera in Nairobi. And on the right, you see actually on the left. Sorry, I'm left and right. So on the left, you see exactly the fire which I showed you on the first slide on the fire of the toy market, which destroyed the market and surrounding areas. And the left shows the present situation, and the right shows the future. This youth organization hopes to have coming up. So that's, I think, the end of my story. Thanks for listening to me and looking forward to your questions.
Thank you so much, Monika. Thank you so much for sharing so many interesting examples of how we can use satellite images, but also additional spatial data in order to map poverty, inequalities, and the associated problems with these challenges that a lot of people around the world are facing. We have a few questions. And I will start with the first one. How do you address different forms of inequality in your projects, particularly in risk assessment and mitigation strategies?
That's a question I think I can. So how to address different forms of inequalities, and that's basically, I think it starts and goes back to this conceptual framework we were showing about the IDEAMAPS, the domains of deprivation framework. That's often, and we are debating a lot between us in a large network of IDEAMAPS and colleagues. So what we often, and what you see also in standard scientific publication is like people map from Earth observation data, they map like the informal settlements, the slums of this planet, typically mainly in one city, but there are more and more studies also to map those on a larger extent, like even like continental scale maps. But it doesn't provide any insights about the differences of those spaces. So like if you, on the background, I have a photo I took also in Medellin, in Colombia, and you see the houses are very different in terms of housing quality. The areas are very different as compared if you go to like just the graffiti we saw before from Kibera area. So it's important to, and that's what I was trying, maybe in a bit more confusing way, to put together to show that we're trying to really look into the different aspects of what defines deprivation. So like the difference in terms of heat exposure, the difference in terms of flood exposure / vulnerabilities, access to green spaces, access to open spaces, also access to transport, or can my area being accessed by a fire truck or not? Is my waste being picked up? So there are so many aspects that make an area less or more deprived, and therefore we really argue to use this more context-specific information to produce information. What are the specific issues of an area, which provides local actors, meaning local government actors, with information what would need to be changed for an area, where to invest, particularly into an area. And this whole model of deprivation is actually coming from an since long done mapping approach done in the UK, in English, in Scotland, in Wales. They use, for example, they developed the English Deprivation Index, where they basically use this as an instrument for municipal or for government investments into areas to understand what are the specific issues into an area. And that's what we are trying to do with different approaches. So on one, the deprivation model, on the other hand, understanding the sort of the livability of areas, which is more like a bottom-up approach from citizen to also to use the perception of how people see areas. Because sometimes we are surprised, like we have been done a study on livability, where we compared Dutch livability perspectives with the perspective from Ghana. And Dutch people always were very excited and very happy if they see water. while local people were not very excited if their house would be close to water, because water means danger, it means flood, but it means also pollution and all kinds of risks coming from the water. So the local context is so important, and also the perception of people is so important, what defines for them an pleasant and livable space. And this is important for developing local actions. So I'm not sure, hope to answer the question partially.
I think it's, yeah, indeed. And indeed, livability is such a subjective concept. I played myself with the app that you mentioned, and I also have my own criteria of defining livability that turn out to be different than the criteria used by other colleagues. Now, let's move now to the data that you are using. And in your presentation, you mentioned that one of the challenges is related to the complexity of data. And we would like to know, what challenges are you referring to? Are you referring to the timeliness of the data, spatial coverage, content accuracy, reliability, or all of them? Or can you elaborate a bit on the data quality?
So that's maybe starting again with the example of the English deprivation index. So this is basically a wonderful index which works very well in the UK because it has a census, it has a very developed registration system, so it has very high quality data. If you want to apply this method in a context like Sudan, you don't have the data to do so. So therefore, like, we were developing ideas in trying to combine local data set. In the case of Sudan, where we also were building a deprivation index with Earth observation data to fill the data gaps. And then, of course, like, you have the problem that some of the local data, they might be incomplete, outdated. You have a lot of consistency problem also with global data sets. Which we noticed, for example, in Sudan, that the hospitals, which were marked by OpenStreetMap, were not in accordance with the hospitals marked by the local data set. So we had to need some local colleagues who were checking what data set is actually the sort of correct one or more correct one. We did a similar sort of check on the location of toilets, and basically we noticed that the toilets in informal settlements in OpenStreetMap are often very outdated, because information in OpenStreetMap gets added, but often not deleted if they are changing or disappearing. So there's a lot of problems with data quality, consistency, temporal differences, and that's something to, very crucial, but very complicated to deal with. And in any model, let's say, you will have data which will have its problems. So I think the most important thing will be also to document and to make also for users of data sets, output data sets clear what are the problems and consistency problems of the model.
This is a very nice transition to the next questions. There are a few questions which are related to the upscale and the uptake of the results that you are presenting here. So what are the key challenges besides those that you have already mentioned when it comes to convincing the decision-making stakeholders that this is important data to be used when they take a decision at different levels? So what are the challenges, and how do you address those challenges, or at least some of them, in the projects you are leading and co-leading?
So it depends a bit on the type of project. So we have like a more, I would call it a more easier project, which is IDEATlas, where we are basically working directly together with UN Habitat and UN Stats, because they are basically the sort of the main, like in a way, like one of the main stakeholders. But we also work in each city, typically with the local governments and the representatives of community-based organizations, to build this whole data mapping approach together with them, which doesn't mean that it will be used, to be very frank. At the local scale, we are basically very much supporting the moment UN Habitat on their thinking about a new Earth observation-based SDG indicator. In IDEAMAPS, we have a very different, a much more grounded approach. So we are working as part of the project. We have, and we are getting a bit of funding for the participating in the project. We have representatives from the local government as part of the project, and we build information systems that are where they see the benefit for their daily operation, and that's, I think, a very important aspect to take. People with whom you think these are the users of your information, that you start the project together with them and build sort of data and information system that makes sense to them. In other works, we are basically doing a lot which are very grounded and community-based work. We are typically starting from day one on with collaboration with local community groups. Also building a lot on our connection with larger networks like Slum Developer International, who are also very much interested in spatial information and information systems. So they are, for example, by themselves are working on a new version of their spatial information system, which is Know Your City data site, which they are in the moment redeveloping. And we are trying to see how we can link basically what we are building together, what they would like to have on this website, and to see how we can sort of collaborate with them. So that's very important for us to build, sort of to have information built on that sort of support local actors. And in general, let's say, I think one of the sort of starting point of many of those projects was that a very frustrating sort of experience I had many years ago, where we also were working together with UN Habitat, and we are putting a big pitch together for the United Nations on particularly investing climate funding into the urban poor. It was called Building the Climate Resilience of the Urban Poor. Mm-hmm. Because also in nowadays, I think the figure is about that only, I think it was 3% of the climate fund goes into the urban poor in the global south, basically, which are most impacted. Yeah. So we had this big pitch. We were working like for almost 2 years, it was a huge network, but huge international network. I was chairing one of the groups. We would put this huge pitch together, and it was like people like it basically means a pitch is that you get the interest of member states. And we failed. And we failed because the main critique was that there's not enough evidence of why particularly climate funds should go into the urban poor, and why not generically into global south countries. And at that state, and it was true, we were really struggling to find evidences to prove data that how much more a person living in an informal settlement is exposed to extreme temperature, how much more a person living in an informal settlement is exposed to regular floods. There were very few global evidences and very few studies to stress this at that moment. And therefore, producing such evidences is already, I think, a step forward to stress policymakers to invest more in those spaces.
I completely agree. And all the projects and the efforts you are putting towards generating this evidence, I'm sure that at a certain moment will lead to better uptake and upscale by the decision makers, and also because the end result is to make sure that we improve the livelihoods of the local communities. Now, talking about local communities, in several of your projects, you involve the communities. So one of the questions is related to how difficult it is to have the local communities involved in data collection, data interpretation, and what strategies you are using to convince them to be part of your story, of your projects, and so on.
No, it's a very good question. And it's basically, I think it needs to be clear, and that's something which I think, so I'm very strong, and this of course depends to place to place. Like if you do like a survey in Kibera, which is one of the most famous informal settlements on the globe in Nairobi, people are really saturated. Like there's every second day it's a bit exaggerated, a researcher hopping by and saying, "Oh, I want to collect some data from you. Can you please half an hour time for me?" And people say like they were very willing, and people like in Kenya are super friendly. So they're often really like very willing to support, but they got more and more frustrated about that. None of the information ever flows back to them. They don't understand how this information is used, and in some places, and it depends on, particularly in places where there's regular evictions are happening, people are afraid, like how this information will be used, maybe against them. So important aspect will be to involve local organizations, but also thinking about from the start on that data collection should be not a one way, but you need to think about what is the benefit for people participating, so what they get back. So for example, like in any activities we do, like small scale of training, which people find very sort of, and we develop this idea of what this training should include, together with our local context or contacts from community-based organizations, to understand what type of training activity people would benefit. And out of this idea, also we developed like a whole training curriculum for community-based organization on how to professionalize. One thing what we also continuously get as a feedback, and that was also a strong drive of the training material. So we typically collect data, not we collect data, but we have community-based organizations as co-researchers collecting data, because if I go in an area, people will find it very awkward, me sitting in front of the house asking for something. But if they see our local partner doing this, it's very different. So that's an important element. Basically, but also then with our local partners who are our co-researchers to train their capacities, meaning that people are very good with data collection. But what we noticed that people really want to develop their capacity on data analysis, on data management, and that's something which we really, I was spending the last weekend in doing some training activities with one community-based organization to improve their skill sets.
This is a wonderful transition to actually my last question, because our project ASTRAIOS is also about identifying the skills that we need in order to make sure that we take advantage of different satellite images and data sets that we are collecting. So now, if you would make the top maybe 3 or 4 skills that we need in order to extract meaningful information from these data sets, what would be those?
The top 3 skills.
You can also say 5.
I think, let's say, at least my starting point, let's say, we as researcher, I think it's important, like we are typically curiosity driven, but we really need to, we shouldn't do research as on the individuals. So it's important, I think, to build collaboration with researchers, because there's so much competition. The competition is increasing with our funding situation, etc. But I think it's still really important to work in collaboration, because people benefit in collaboration. So we, for example, we open also a community of practice where we bring more junior modelers together to learn from each other and to build collaboration around this topic. It's really important, and that's something which I see that a lot of people do Earth observation mapping behind their computers, building reference data which are locally meaningless. So the local context is really important to get an understanding of what you are mapping, and also and understand where this data is actually useful or maybe even harmful. So the local context, I think, is important. And to me, the pairing between Earth observation and citizen science is, I think, the way forward that we make. which of course links also to the local context, but also into bringing Earth observation and a passion about working with Earth observation data into a more mainstream sort of societal debate. And that's, let's say, also in the global north, like I have colleagues working with schools to bring Earth observation data into the schools. And it's often like also in the context of all the right-wing and climate neglecting people, it's important to show people how, like an thermal image, and to show the surface temperatures, but also to show it together with grounded measurements. So to open up to non-scientists Earth observation data, to not live in our towers where we observe and are disconnected with the rest of the world.
Thank you so much, Monika. Thank you for sharing all these meaningful insights into how we can use data sets from the downstream space sector to address important international challenges such as poverty, inequality, helping us to put all these local communities on the map of climate change vulnerability. I think it is amazing work that you are doing together with your collaborators. And now for our community, it's important to spend time to develop, of course, soft skills like teamwork, learning how to communicate our results so that we can enable the uptake and the upscale. So basically, the decision-making organizations can use the data set. And besides this, we also need to develop the skills related to how we can extract the information from Earth observation data. Thank you so much for your time. I'm sure everybody enjoyed. And for those of you who are interested in following the next webinar that will be focused on digital twins in the urban areas, please register for the webinar that will take place on the 1st of October at the same time. Thank you so much for being with us here today.